Okay, so this is action code A, dealing with calculating the molecular mass of a variety of compounds. So this is your syllabus here, your board rather, and this is taken from this section of your syllabus. If we zoom in, so this is unit 2.1 and it's statement G. Okay, you need to be able to calculate relative atomic masses and relative molecular masses. Okay, so these all these compounds here are taken from earlier work, so hopefully you'll recognize them. So this one here has got is NH3, which is known as ammonia. And if we have a look at our periodic table, we can find that the mass of nitrogen is 14 and the mass of hydrogen is 1. So there's 1 nitrogen, there are 3 hydrogens. So if we multiply that out, we get a final MR of 17. Okay, if this was the molar mass, then that would be grams per mole. But for now, we'll just leave it as a figure. This is sodium chloride. Okay, so we'll fill that one in. And sodium chloride we consider to be a 1-to-1 ratio of sodium and chlorine. So if you look up the mass of sodium, it is 23. And the mass of chlorine is 35.5, which is there. Okay. That gives us 58.5. This chemical here, again, you can recognize it from earlier work. It's very popular in the exam. This is methane. And it's got a central carbon and 4 hydrogens. So its formula is CH4. If you look on the periodic table, carbon has a mass of 12. There's one of those. And hydrogen, as you've seen earlier, has a mass of 1. And there's 4 of those. If we multiply that out, we get 16. And then finally, sulfur dioxide. So from the name sulfur dioxide, we can probably work out it's SO2. And then we could use 3 circles. And for the benefit of this task, it doesn't really matter how you differentiate them, because neither oxygen nor sulfur appear in any of the previous models. Okay, so use that key there. Sulfur has a mass of 32. Oxygen, of which there are 2, has a mass of 16. So that gives us 64. Okay.